This is the 7-1B lesson that video that's going to go over the birthday slide and kind of talk about this. So first off, we'll look at the results that, and this is anonymized, that 23 students out of about 24 thought that this would be a function. In the other class period, 23 versus 5 students. So overall, we feel like this is a function. And this was a perfect justification. I think this will be a function because no students have two birthdays. And that is the key part to this, that one person can't fork to two different birthdays. Um, if we look at the other class, we see some arguments that also say that each input has one output, everybody has only one birthday. And then there's these other justifications here that might have caused some people actually to say no, even though this person said yes, which is everyone will most likely have a different birthday. Well, even if people have the same birthday, that still uh, f- meets the requirements of something being a function. And in fact, it is a function regardless if people have the same birthday, because you are allowed, if you recall, to have, I'll try to sketch this. Let's say we have person A and person B, and we have some birthday over here. My birthday is on the 25th of April, and they share the same birthday. In fact, me and my son, this is real, share the same birthday, but it still passes the test of um, being a function because I only am paired with one birthday. It's okay if I reuse this. This is the same reason that a horizontal line is still a function. What isn't allowed and what would be not a function is if this somehow forks. That person B has two different birthdays. So this is always a fun experiment to look at and to collect justifications because, like you saw, sometimes it's difficult to understand that even if we had people share a birthday, this would still actually be a function. And in fact, I'm going to show you the data. I've anonymized it, but you can see this is for both classes. Got about 48, excluding the top row, 48 sets of data. And in fact, oftentimes people, when they think about this question, they say, well, it's probably not that likely that people have the same birthday, even though that wasn't necessarily part of whether this would or wouldn't be a function, because it is a function. And in fact, people did have the same birthday. Um, and there probably should be people with the same birthday, even though this seems like for your chances to be 50%, that you'd have to have, 180 people in a room. In each class, there's about 30 students. You can see that here's a pair of people that had the same birthday. The red ones are the ones that are for students that are in different class periods. So that kind of makes this a bit unique. Normally, we look at this within just one class. Here's another set that was in different class periods. Here's actually two people with the same birthday within the same class period. And up here's another one. And so this actually is known, function and non-function aside. And by the way, this is a function. This is allowed to share outputs. Um, this is a little graph. I'll also post this. I did not derive this equation. You can Google birthday paradox, and there's lots of different pages on this. I'll also post a video that does an even better job explaining this than I'm probably doing. But this video, or excuse me, in this video, I'm going to show you this graph, which shows you the number of people, which is X. So right about there, when you have about 22 people in a room, 22 people, that's it. You have about a 50% chance that two people share the same birthday. We had about 30 people in one class period. We had about a 70% chance. And then, although I didn't get everyone to submit this, but if everyone did across the two class periods, we had about 60 students altogether, which means we had about a 99% chance of two people sharing the same birthday, excluding the year. And in fact, there were one, two, three, think there was scrolling too fast. 4 sets of shared birthdays. Again, this is the birthday paradox. And even just within a normal class size, you have a pretty solid chance. Although we did see also with the other that in one of these classes, there was not actually a shared birthday. That this would have been in zero period. And there was not actually a pairing in third period, although there was a pairing, several pairings across zero and third period. So that's kind of cool. Um, and then I would definitely check out the follow up to this, which is a number file video that I'll post with this, and I'll also post the graph.